Okay, nice friends. Here we have 2 over x multiplying 2 over x. Are we there? To be equal to x over 2. Does this make sense to us? Very good. To solve a problem like this, of course, we carry out this multiplication and we have 2 times 2 upon what? X times x. Good. So we have 4, are we there? Over what? X squared. Does this make sense to us? To be equal to x upon 2. Good. So if this is true, we can do what here? Cross multiply, right? Very good. And now we have x cubed, okay, upon what? Sorry, x cubed to be equal to what? 8. Good. At this point, one may suggest that x, of course, becomes equal to what? The cube root of 8. This is very correct. Are we there? However, we have this rearranged to become a polynomial where x cubed minus 8 will be equal to what? 0. Good. Because we have a degree of 3 here, it means that we expect 3 roots. Are we there? Very good. And this is what we are going to find out. So this being equal to 2, actually, is only one root of the equation. Does this make sense to us? Very good. So we have just one result here. Then there are two other what roots for this what polynomial. And that is what we have to solve out now. Let's do this together. Of course, x cubed minus 8 equal to 0. I can rewrite this to be equal to what? S cubed, right? Minus 2 raised to the power of 3 to be equal to 0. I have done no change here. I've only rewritten this equation. Does this make sense to us? So here we have the difference of 2 cubes, right? Very good. We know algebraically that's what? A cube, right? Minus B cube, right? Is equal to what? A, okay, minus B, multiplying A squared, okay, minus what? Or rather plus AB, out there, plus what? B squared. This is an algebraic identity. So it is this algebraic identity that we're going to use to form the expansion of this, right? Good, where A is equal to X, B is equal to 2, right? Very good. And so we have x minus 2, good, multiplying, x squared, good, plus 2x. Remember that a is equal to what? X, and b is equal to 2, right? Good. Then plus 2 squared. Of course, equal to 0. So now, from the zero product law, right? Good. It means that x minus 2, which has been gotten already, will be equal to 0, and this implies that what? X is equal to what? 2, one of the roots of the equation. Good. So further using the zero product law, we'll equate this to what? 0. So we have x squared, plus what? 2x, okay? Then plus what? 4 to be equal to 0. 4 gotten from 2 squared, right? Very good. So solving this further, friends, we have this as a quadratic equation, right? Good. And if we compare this with ax squared, okay, plus what? Bx, plus c to be equal to 0, where a, b, and c are coefficients, right? Are constants, rather. Good. Comparably, a is equal to what? 2 is equal to 1, the coefficient of x squared. Are we there? Very good. And b, is equal to 2, the coefficient of x. C is equal to what? 4, the constant of the equation. Good. Solving quadratically, we have that x is equal to what? Minus b, okay, plus or minus the root of what now? B squared minus what? 4ac, everything upon what? 2a. Good. This is the solution to the quadratic equation. And this is what I call the general formula, right? Very good. Substituting now the values of a, b, and c in this particular equation will give us the value of x. So we expect two roots here. Since we have gotten the first root as x being equal to 2, we expect what? Two other roots. So this is x1 here. Are we there? Good. So let's go. A is 1, b is 2, and what? C is 4, right? Let's do this already. So we have b now, minus b. So we'll say x is equal to what? Minus b. What is the value of b? B is 2. So we have minus 2 plus or minus, right? The root of what now? B squared. B squared, b being 2, we have 2 squared as 4, right? Minus 4ac, where a is 1 and c is 4. So 4 times 1 times 4 will give us what? 16 here, right? Very good. All upon what? 2a, and a is 1. So we have what? 2 here. Good. So remember that this should give us two roots. That is why we have plus or minus here, right? Well, let's simplify this further now. We have that what? X is equal to what? Minus 2 plus or minus what? The root of what? Minus 12 here, right? Good. So we have minus 12 here. So if we have minus 12 here upon 2, good. You realize that what this root here will result to a complex root, right? Very good. And minus 12, good. We can rewrite as what? 4 times what? Minus 3, right? Very good. And that is the substitution we'll do here. So introducing the root sign now, okay, we have what? 2, the root of what? Minus 3, right? Very good. And the root of minus 3, we can still break down to give us what? The root of 3, good, times what? The root of what? Minus 1. And what is the root of minus 1? The root of minus 1 is what? An imaginary number, iota, right? Good. So we have what? The root of 3 here multiplied what? Iota. And that is what we are going to use as our substitution, not forgetting 2 here, right? Very good. So we have 2 root 3 iota representing what? The root of minus 12. So we do that substitution here and we'll be having x, right? To be equal to minus 2 plus or minus, okay, we have 2 root 3 iota. Very good, friends. Everything upon 2. Right? Very good. So if we have this now, x, okay, becomes equal to. So you realize something here. We can factorize 2 here, right? And the numerator, since we have 2 at the denominator. Does this make sense here? Good. So what it becomes now, x becomes equal to what? Minus 1 plus or minus, okay. We go, the root of 3 iota. Very good. We have removed the 2 at the denominator now, right? Good. At this point, we can say the second root here, taking the positive sign now, friends, is equal to what? Minus 1 plus what? The root of 3, iota. And the third root here becomes what? Minus 1 minus the root of what? 3 iota. And we are done solving. Not forgetting that what the first root we got was x1 to be equal to what? 2. So here lies our solutions, right? Very good. Do not forget to subscribe to the channel if your first time coming around and it is your friend Show Success. Thank you. Like and leave a comment.